Okay, good day, class. All right, so today we will continue with 5.2.4. All right, so last lesson we have we have finished all the parametric equations of circle, ellipse, and parabola. All right, so today we will go to the last one, the parametric equations of a hyperbola. Huh? So again, the parametric equation of a hyperbola can be represented in two ways. One is in the trigo one, and one is the terms of parameter t. We will discuss both. All right, so 5.2.4.1 parametric equation of hyperbola. Okay, so if you are having a hyperbola, let's talk about a hyperbola at the center at origin. All right, x squared x squared over a squared minus. Remember, hyperbola is minus y squared over b squared equals 1, with center 0, 0. So this one is x squared minus y squared. Remember, x squared minus y squared means it's a horizontal one. Then can also be defined by parametric equations. So let's say we have two parametric equations. X equals a secant theta, secant 1 over cos, and y equals b tangent theta. Where a is this a is same as this a, this b is same as this b lah. Okay, so let's say when we sub these two parametric equations x, y into the left hand side of the standard form of the hyperbola, so we will see if we can get back 1, then yes, it is the parametric equations of hyperbola, right? So this is the left hand side of the standard form of the equation of a hyperbola. Then we sub in the x and we sub in the y. All right, so after you elaborate, you have a squared secant square over a squared. Okay, so a squared and a squared simplified, b squared and b squared simplified. So left, secant square minus tangent square. And you will still remember the basic trigonometry identity. Secant square minus tangent square is 1. Remember, we have three basic trigo identity. The first one is sine square plus cos square equals 1. Remember? So another one is this one. 1 plus tangent square equals to secant square. This one. This is the second one. Alright? So when you shift the tangent square to this side, therefore secant square minus tangent square is equals 1. Okay, so we start with the left hand side. When you sub in the parametric equation, we get back the right hand side 1. Alright, so hence the equation of the locus of point P can also be written as this one, of a hyperbola, of course. And at any point of the hyperbola, it has a parametric equations. Okay, so for your information, this is for x squared minus y squared horizontal. So how about the vertical one? Also remember the vertical one like this? Alright, so we know that the vertical one is actually y squared minus x squared, right? Alright, so if it is vertical one, y squared minus x squared, then the parametric equation will be x equals a tangent theta and y equals b secant theta. See, just now is x is secant, y is tangent. So if vertical, then x is tangent, y is secant. Why like this? Because after we square it, what we want is secant minus tangent. See that? What we want is secant square minus tangent square. It must be secant square minus tangent square. Alright, so if y equals secant square, then only you get y square minus x square, which is the vertical one. Alright, okay. So we will see some example. Look at your textbook, checkpoint 5.6. Okay, page 245. So we will discuss question 4. All right, we will discuss question 4. So question 4 is like this. All right, so this is question 4. So each of the following parametric equation represent a hyperbola. Find the Cartesian equation of each hyperbola. So they give you the parametric equation. They want you to find the Cartesian equation and determine the foci and the equation of asymptotes. All right, then after that, sketch the hyperbola. So I'm going to discuss A and D. All right, so please drop down. B and C will be your homework. All right, okay, so let's see. Okay, let's see. All right. Okay, so this is question 4A. All right, so you are given the parametric equation, x equals 4 tangent 2 theta, y equals 3 secant 2 theta. So whether it's theta or 2 theta actually doesn't matter. Oh? Okay, so I square both sides. So x square, 4, shift it here. So x over 4 lah. So square both sides. So I have x square over 16, tangent square 2 theta. This one also, 3 shift it to this side, y over 3. So after square, you get y square over 9. So secant square 2 theta. Alright, so remember the identity is secant square minus tangent square. So this one minus this one. Alright, so y square over 9 minus x square over 16. So secant becomes secant square 2 theta minus tangent square theta. So we apply the identity. Oh, doesn't matter it's theta or 2 theta, as long as their angle are the same. So secant square minus tangent square is equals to 1. Alright, therefore this is the Cartesian equation of the hyperbola. Alright, so because it is y square minus x square, so we know that it is a vertical one. Okay, so you can refer to your notes page 21, the table. Alright, how we can get the center, foci and asymptote. You can refer to your notes page 21. Okay, so this one very clear. Center is 0, 0. Alright, and we know that c square is a square plus b square. This is a square, this is b square. This is b square, this is a square. 25. And foci related to c, right? Because this is a vertical one. Vertical one. So the major axis is like this. It's a vertical line. So we know that all the x are the same. All the x are the same. So the y will be plus minus c. So c square 25, c is 5 lah. So the foci will be 5 and negative 5. Alright? And the equation for the asymptote, this is center origin. So the equation of the asymptote is plus minus b over ax. B is 3. A is 4. Remember, B is under y, A is under x. So it's y equals 3 over 4x and y equals negative 3 over 4x. Alright? And how to sketch the graph? Still remember we use the simple way lah. Alright, we use the easier way that you draw the rectangle. Alright, so we prepare the axis. Alright, because this is vertical one. So y is 3, right? So from center, this is center origin. So B is 3. So from center, 3 unit up, 3 unit down. A is 4. So from center, 4 unit left, 4 unit right. Okay, so you draw the rectangle. Then the diagonals. Remember, the diagonals will be the asymptote lah. Must pass through the, my diagram is not that accurate lah. So this is the asymptote. That the diagonals of the rectangle and must pass through the center. So these two are the asymptote lah. Alright, then the hyperbola will be, because it's vertical one, and this is the this is the vertex. Remember the vertex. Okay, this is the vertex. So it's like this. These two, 3 and negative 3. Okay, here is the vertex. Alright, cannot see. Okay. So this is the diagram. So it's easier for us to draw the asymptote lah. No need to calculate the points to draw this true straight line. Alright? Foci up to you lah, whether you want to mark or not. Alright, so foci is 0, 5. So if this is 3, 4, 5 will be somewhere here. 3, 4, 5 somewhere here. These two are the foci. Alright? Okay, so this is 4A, where the center is at origin. Okay, we'll see another example, which is D. Alright? So question D, you are given x equals 3 secant theta plus 1, y equals 2 tangent theta. These are the parametric equation given to you. So can you compare, you see. Just now, this one, x is tangent, y secant. But this one, x secant, y tangent. Right? So it can be shift lah. Okay, so before squaring, we have to rearrange it. So first, plus 1 shift here, minus 1. So 3 here, over 3. Alright, so you get this. So this one, 2 shift here, like this. So I square both sides. Alright, this one also square. This one no need to expand, just make it like this. Okay, then I use this one minus this one because it must be secant minus tangent. So now it's x minus y lah. Then right hand side is x minus y, left hand side is secant minus tangent. So secant square minus tangent square again is 1. Alright, so you get this, the Cartesian equation of the hyperbola. This is the standard form, standard form. So again, when you see x square minus y square, so I know that it's a horizontal parabola. Like this. So center, very simple, 1, 0. Center. Okay, c square, a square, same. A square plus b square. This one plus this one, 13. Alright, okay, foci. So you know that this is horizontal. So the major axis is a horizontal line. So if horizontal line, all the y are the same, right? All the y are the same. So y from the center, y is 0, so 0, 0 also. Okay, then what is the focus? Yeah, so the focus will be 1 plus square root 13. Or 1 minus square root 13. The h plus c, h minus c. Okay? So this is the foci. And the asymptote. Alright, just now at origin, the formula for asymptote is this one. Alright, so if the center is not origin, then the formula for asymptote is this one. Y minus k plus minus still b over a, x minus h. Alright, so y is still 0 lah, or y is still y lah. So b is this one, 2, a is 3. So 2 over 3, so x minus 1 from here. Alright, so one is positive 2 over 3 x minus 1, another one is negative 2 over 3 x minus 1. Okay? So this is the solution. Alright? Okay, then next, diagram. Sketch the graph. Alright? So same lah. We label the axis. Alright? Center is 1, 0 here. Center is 1, 0. Alright? So B is 2. Okay? B is 2. So from the center, 2 unit up, 2 unit down. Okay? Then A is 3. So from the center, 3 unit right. So 4 lah. And 3 unit left. So negative 2. Okay? So we draw the rectangle. Okay? So again, the diagonal. So the diagonal must pass through the center lah. My one maybe not that accurate. Okay? So the diagonal of the rectangle and must pass through the center. So these two are the asymptotes lah. These two red one will be the asymptote. Okay, now we draw the hyperbola. So it's a horizontal one. Alright, so this is a vertex lah. Negative 2 is a vertex. Yes. So yeah, then 4 is a vertex. This one maybe more space. Okay. So this one the vertex is negative 2, this one the vertex is 4. So you get your hyperbola. Alright, it's just some revision about hyperbola. Just that now we are using parametric equation. Alright. Okay, so I have discussed 2 questions. So you do another 2, B and C as your homework. Okay. Alright, next. Okay, so next. One more, sorry. Before, just now we said already, right? What we have discussed just now, we are using parametric equation in trigonometry, tangent and secant. Alright, so we will see one example where we get the parametric equation in parameter t, not involve trigo. So actually you can see in your textbook. Alright, you can see in your textbook, page 244, page 244, example 5.27. Okay, example 5.27. Maybe I enlarge a bit. Okay. Alright, so this is a question. You see? So you see, a curve is given by the parametric equation x equals 2 square root t minus 1 over t, and y equals 2 square, sorry, not square root bracket, 2 bracket t plus 1 over t. Alright? So you have to remember one thing, it is the parametric equation of the hyperbola, if in trigonometry, is quite standard. It's quite standard. A secant theta, B tangent theta, or the other way around. It's quite standard. But if it is in parameter t, then we don't have a standard form. This is not the standard form. This is not the standard form. They don't have standard form. That's why we seldom use. Okay, so we normally use the trigonometry parametric equation. Alright, then show the curve is hyperbola. Then determine the foci and the equation of asymptotes. Sketch the hyperbola. Alright, we don't have, okay, we have one equation here. We have one example, we have one question 4. Okay, B is the parameter, later you can refer to this example. Okay, so x equals this. So I shift 2 to this side, you get this. Then y equals this. Then we shift y to this side and get this. Alright? So 1 plus 2. Because we want to find t. We want to find what is t. So if 1 plus 2, we can eliminate the 1 over t. Alright? So equation 1 plus equation 2. So t plus t, 2t. Negative 1 over t plus 1 over t, no more. So this one plus this one. Okay? So t equals to this. T equals to 1 over 4 x plus y. Alright? Then you sub t into equation 1. You sub t into equation 1. You can actually, it's up to you. You want to sub into equation 1 or equation 2, both can. Because our purpose is to eliminate the parameter t. Alright, so for this example, they sub into equation 1. So 1 over 4t is, so t is 1 over 4x plus y, minus 1 over t, so minus 1 over, so this is t, equals to x over 2. Then the next step is actually just simplified. 1 over 4 means 4 upside, this one down. Okay, this is the first step. Next step, the whole equation multiplied by x plus y. Sorry, it's multiplied by 4x plus y. 4x plus y. So this one multiplied 4 and 4 simplified, so x plus y squared. So this one multiplied 4, 16, x plus y simplified. So this one, 2 and 4 simplified, left 2. So x is still remain and x plus y. Okay? Then after that, you know that to make it standard form, we have to elaborate. We have to elaborate to separate it into x and y. So after elaborate and simplify, you see, become y squared minus xy. Minus x squared. xy, no, 2xy no more, equals 16. Alright? And we know that for hyperbola, ellipse and hyperbola same. The right hand side must be 1. Just that ellipse is plus. Okay? And hyperbola is minus. So the whole thing divided by 16. So you get this. Alright? So remember, for hyperbola, the a and b can be the same. But this one minus. Alright? So you get the equation of the hyperbola. So this is the standard form of the equation of hyperbola. So it's already showed the curve is hyperbola. Alright? Then next step, determine the foci. So this one, clear, center, origin. Alright? C square is a square plus b square. Okay, hold on. I think some mistake here. This is not foci, this is vertex. Alright, there are some mistake here. Okay, this is not foci, this is vertex. Alright, A is 4, B is 4. Alright, so 0, 4, 0, negative 4 is actually vertex. Vertices. Alright, foci is C square A square plus B square. So it's 32. Alright, so 32 is 16 times 2, right? So 4 square root 2. This is C. Foci is this one. Alright, this is vertex. So there's a mistake here. This is vertex. So foci will be 0, 4 square root 2 and 0, negative 4 square root 2. Can? Clear? Alright, so the equation of the asymptote, same Okay, because this is in parameter. The equation of the asymptote. No, we don't use this one. Okay, I don't know what they write it in terms of t. No need. It's not in terms of t. Okay, the asymptote is equals plus minus b over a. So 4 over 4x. Alright, which is y equals plus minus x. This one. Alright, you see or not? Y equals x, y equals negative x. The sketch out, because the question asks you to sketch, right? And this is y squared minus x squared, so it's the vertical one. Alright, the asymptote is y equals x, y equals negative x. So this is the, you see, 0, 4 is a vertex. They have some mistake here. Okay? So this is the parametric equation of hyperbola in parameter t. So there are two types, like question 4 here. Okay? It can be in trigo, it can be in just parameter t. Alright, so to do this question B, you can refer to this one. So you will get the answer. Alright? Okay. So, sorry, it's moving. Alright, so next we'll be going to Alright. Okay. Alright, so next we'll be going to 5.2. Sorry, not this one. 5.2.4.2. Chords, tangents, and normals to hyperbola. It's actually quite similarly to what we have done for circle, ellipse, parabola. We just repeat the same thing. Alright? Okay, let's say x has parametric equation a secant theta, y p tangent theta. Alright, for this hyperbola. So this is the hyperbola with center at the origin. Then next, let's say we have 2 points. Alright, lies on the hyperbola with coordinate p a secant theta, b tangent theta, and q a secant alpha, b tangent alpha. Because 2 different points, so of course the anchor also different, right? At different position, anchor different. Alright, let's say these 2 points will be the 2 points on the hyperbola. So the equation of the chord PQ is this one. Okay, so how to get this? Okay, how to get this? Alright, if you have this Blangy textbook, can you see? This is the Blangy one. Cannot see, here, like this. Okay, so this is a Blangy textbook. Okay, if you have this Blangy textbook, excuse me. Alright, page 215. It shows very clear how we can get that equation of the chord. Alright, can see it? Okay, so like this. Okay, that's like this, easier. Alright, so you see. Alright, so you have 2 points, right? But this one they don't use alpha they use rho. Same it's just symbol. Okay. So we are using point P. So we use the formula y minus y1. This is a y for P. Okay, m, x minus x1. So m is the gradient. How to find gradient? Y minus y, right? Over x minus x, right? It's from here. So this one got b, this one got b. So they factorize out the b. This one got a, this one got a. So they factorize out the a. See? Alright, then the next step is they multiply the whole equation by 1 over b secant theta minus secant rho. Alright, so y multiply this, so become y over b and secant theta secant rho. This one multiplied with this one, so b and b simplified. So become tangent theta secant theta minus secant rho. Okay? So this one also the same. This one may multiply with 1 over b, so b and b simplified. Okay, secant theta secant rho also simplified. Alright, so left tangent theta minus tangent rho over a. So multiply with x, you get this. Multiply with secant, you get this. You get this, secant, right? Okay, right? The a and a simplified already, so no more a. Alright, Okay, so next step, we rearrange it in a proper way. So x still here. So the y, we shift it to the right hand side, so become minus. Okay, so this one also shift it to the This one remain here. Let's see. Oh, okay. Okay. How to get this one is they elaborate. So you see here got minus tangent theta secant theta. Here also got minus tangent theta secant theta. See? So no more, simplify. Alright, so you have plus tangent theta secant row. So plus tangent theta secant row. Because it's shift it to this side, so positive. Alright, then this one left, secant theta minus tangent row. Alright, they simplify it. Okay, so next step, multiply both sides of the equation by cos theta cos rho. Alright, so you see, I show you just the first one. X over A, tangent theta is sine over cos, right? So tangent rho is sine rho over cos rho. Okay, so imagine when this one multiplied with cos theta cos rho. So x over A remain the same. This one, when you multiply with this, so cos theta simplified. So left sine theta cos rho. See? This one also, cos rho simplified. So left sine rho, cos theta sine rho. See? I explained this one. So this thing also the same. Secant is 1 over cos. So after multiply with this one, you get this. Secant also 1 over cos. This one also the same. Same. Alright? Tangent, you write it as sine over cos. Secant is 1 over cos. So when you multiply this one, you can see where to cross cut it. You can use a paper to write it in a proper way. Then you will see. Okay? So multiply the both sides by cos theta cos rho, you get this. It become like this, like this line. Okay, so the next thing is they are using the sum to product identity in chapter 1 trigonometry. Remember the sum to product formula. No, this is product to sum. Okay, product to sum. No, sorry, it's just I can't remember the name. It's sine A minus B. Remember, sine A minus B is sine cos sine. Use that one. This one also. This one remain the same. Okay, this one remain the same. Okay. Then next is they use actually they use sum to product. Okay, so sine theta minus rho is actually 2 sine half theta minus rho cos half theta minus rho. This is sum to product. From here to here is sum to product formula. This is multiple. Yeah, I remember. Multiple anchor. Additional. Yes, additional anchor formula. This is additional anchor formula. This is sum to product formula. All right. So this one also. Let me see. This one also sum to product formula. This one also sum to product formula. Okay? Yeah. So after you simplify after you simplify, then you get this thing. It's actually just divided by 2, right? Yeah, it's just divided by 2. So this is how we get to this. So this is the equation of the chord PQ. Equation of chord PQ. Alright? You can take a piece of paper and write each step in details so you will see it. Okay, so this is for chords. Alright, then next, the equation of tangent. So remember the concept? The concept is when Q moves towards P, when Q closer and closer to P, then these two anchor the same, right? Theta, when they overlap each other, then theta and alpha same. So this is the equation of the chord. So we don't have to go through the whole step. We just sub in here. So these two anchor are the same. So let's say theta minus theta, 0. So cos 0 is 1 what? So left this one. Alright? This one, theta plus theta, 2 theta. So half 2 theta is sine theta. Okay? So this one also. Theta plus theta, 2 theta. So 2 theta divided by 2 is theta. So cos theta. Alright? So this is how you get the equation of the tangent. All right, and the equation of the normal. So similarly lah, the equation of the normal is this thing. Okay, so how to find this one? So I show you again. You refer yourself lah. I don't go through in details lah. You go through yourself. You can snap down and you go through yourself. All right. So this is how you get the tangent. Get the tangent. All right, and the gradient of the tangent is this one. See, this is the gradient of the tangent. All right, from the equation, they get the tangent, the gradient of the tangent. Then this is gradient of the tangent. Then you can get the gradient of the normal. All right, so when you get the gradient of the normal, and you sub into the formula, I show it here. I hope you can see. Can see? Okay. Okay, can see. I sub in here, so you get the equation of the normal. All right, so you can step down and go through in details lah. All right. Okay, so these are the steps for the equation of the chord, the equation of the tangent, and the equation of the normal. Right, so you see here, the equation of the tangent actually of the hyperbola can be obtained by using the differentiation. Later we have one question related to it, so I would explain to you. Okay, other than use the formula that we stated just now lah. All right, so I will tell you how to get this thing. Because if you don't have the trigo, let's say you don't have the 2 points, just now what we showed just now, this one, we get the equation already ma. So we can rearrange in gradient form. So from there you get the gradient of tangent. All right. So if other way you don't have 2 points, let's say you don't have P and Q, so you can't find the equation of the tangent. Let's say you don't have trigo lah, you don't have the angle theta, right? Then we are using differentiation to find the gradient of the tangent. Later we will show you one example. Okay. So let's see. 2 questions. All right, I only have 2 questions related to this gradient of related to this chord, tangent, or normal of hyperbola. I only have 2 questions. All right. Okay. This one just now we discussed already. 5.27. Where is my? Okay. So question 2 here. Yeah, okay, here. I can't see. No battery. My lamp no battery already, so quite dark already. Okay, brighter. All right. So now I have explained all this. So example this one. Show that okay, I can see. Okay. All right. So show that this point lies on this hyperbola. Okay. So how to show this? Very simple. This is x, this is y, right? So just sub in x and y into the right hand side and calculate, then you should get your right hand side. So same. Start with left hand side. I sub x inside here, like this. I sub y inside here, like this. So I simplify. So 3 square is 9. Square root of 5 square is 5. So 9 times 5, 45. This one 4 square. So 4 square is together with 9, right? So 36. Okay, y square is 4 over 16. So simplify. This is 45, 39, simplified by 9, so it's 5 over 4. This one simplified is 1 over 4. So 5 over 4 minus 1 over 4. 4 over 4 is 1. Okay? Then you can make the conclusion. Alright, you can make the conclusion. This point, I didn't write lah, you write lah. The points 3 square root 5 over 2 and 2 is lies on the hyperbola. Okay? So next step. By finding its parametric coordinates. They want parametric coordinates. Then find the equation of the tangent to the hyperbola at this point. At this point. Alright? So still remember the parametric equation. We use the trigo one. So x is a secant theta, y is b tangent theta. How I know like this? Because again, it's x square minus y square. So x square minus y square is a horizontal one, right? Okay, so if horizontal one, then x is secant. Then only when you square it, you get secant square minus tangent square. So A is 3 from here. A is 3, B is 4. So just sub in. So you get a parametric coordinates because the question say by finding its parametric coordinates Alright, so this coordinates, this one, in parametric form. Okay, so then sub X is this one, right? So 3 and 3 simplify. So I get secant theta equals this. Secant is 1 over cos. Remember? 1 over cos. So cos shift it here. This one shift here become like this. Alright, for the y coordinate also the same. Y is 2. So tangent theta is 2 over 4. 1/2 lah. Okay, so by using the triangle, I want to get sin theta. I use tangent theta lah. Tangent is opposite adjacent. So opposite adjacent. So 2 square plus 1 square, square root 5 lah here. So correct, right? Cos is 2 over square root 5. So sine is opposite hypotenuse. So 1 over square root 5. Okay, so why I need this one? So we will go to the formula. So the equation of the tangent is this one. Remember here? The equation of the tangent is x over a minus y over b sine theta equals cos theta. So sub the value inside only. So x equals a minus y equals b. So sine theta is 1 over square root 5. Cos theta is 2 over square root 5. Just sub in. So of course you have to memorize all this formula. Then to simplify it, I multiplied the whole thing by 12 square root 5. So this one multiplied 12 square root 5, 3 and 12 simplified. So 4 square root 5x. Alright, so 4 and 12 simplified is 3. Square root 5, square root 5, no more. Oh yeah, it's 3y, sorry, it's 3y. Okay, 3y, got 3. Then this one also, square root 5, square root 5 simplified, 2 times 12 is 24. Alright, so therefore y shift here 24 shift here. So y equals, I forgot the 3 Okay, so the equation of the tangent is 4 over 3 square root 5x minus 8. It's supposed like this. Can. Alright, it's supposed like this. I forgot the 3 Alright, so just apply formula which related to tangent. Alright, but because the equation of tangent involves trigo, right? So you need the parametric coordinates so that you can find tangent theta, cos theta, and sin theta. Alright? Okay. So now the difficult one. It came up once in STPM 1999. Long time ago, before you born, right? Before you born. Okay, I'm not going to discuss this, but I will explain to you how to get the answer. Alright, so I want you to work it out as homework. Don't worry, not quiz, as homework. I want you to work it out. So I give you 1 week time. Okay, by next Wednesday, you have to upload the solution for this question into the Google Drive as homework. But I will tell you how to do it. It's quite long. I want you to do it one by one step, simplified slowly. You can do it. No, don't worry. Okay. All right. These are the. Let me see. Can see now this the last. Okay, can see the whole thing already, Okay. All right, can see the whole thing. Okay, so listen carefully how to solve this question. Okay. Oh, I see. I have to move it up a bit here. Okay. Alright, so the first question, show that the point P with this parametric equation, they are given in parameter T, lies on the curve, this one. So you see, when I see x squared minus y squared, I know that it is a hyperbola. And it is a horizontal hyperbola, right? Because x squared minus y squared. Okay, so how to show it? It's actually just like this one. Just like what we have discussed. But this one, of course, as I say, is longer. Alright, so what you need to do is you sub the x and y coordinate of point P into the left hand side of the hyperbola, equation of hyperbola. Alright, simplify it, then you will get the right hand side. So this question, you sub x equals this one, y equals this one into the left hand side here. And then you simplify, of course, involve a lot of terms. Slowly simplify, you should get your final answer, a squared equals b squared. Alright, step no problem, just involve a lot of terms, so be very careful. Okay, second part, show that the equation of the tangent to the curve at point P is this one. So you see, they give you the equation of the tangent. So the problem is how you get this thing. Alright, you see, this one they are not given you in trigo. Not like just now. Just now they give me figure, I can use trigo. Alright, this one they give you in parameter already, so you cannot use trigo here. Okay, so how to find the equation? Remember just now we say here, remember? We can find the gradient of the tangent of hyperbola by using differentiation. Actually, this differentiation of implicit function I have discussed before. Even though it's second sem syllabus lah, but I have discussed before. Okay, so okay, let's look at it. This is the hyperbola, right? So we know that the gradient of the tangent is actually dy dx ma. Now the problem is how to differentiate this one, right? Very simple. We differentiate terms by terms. Okay, so first differentiate this one. So b square, copy. Differentiate x square is 2x, right? How to differentiate y square? This is the implicit. I hope you still remember. Actually, very simple. So a square is a constant, copy. So differentiate y square. So as usual, differentiate y square, index in front, index minus 1. So differentiate y square, you get 2y. But please multiply with dy dx. This is the only step. If you differentiate, because we differentiate y with respect to x, x is our variable. So when you differentiate x, no problem, just do as usual. But now I'm differentiate y. Not with respect to x. So I differentiate as usual, but after I differentiate, I multiply with dy dx. That's it. Okay? Then this is constant ma. So differentiate constant, 0. Okay? So you have differentiate. So we want the gradient of tangent is, we want to find dy dx. We want to find dy dx. So how? Again, you sub in your x and y. At point P ma, right? So this is your x, this is your y. Okay, so sub your x and y in this one. Sub your x and y by using this. Okay, then again, simplify, rearrange until you get dy dx. You sub in, then you rearrange, move here and there, expand until you get dy dx equals something. Okay, again, this step is quite long because involve a lot of terms, right? Just be careful. You can do it. You do it carefully, step by step. All right. Then, since you already have gradient and you have point P, so sub into the formula. Y minus y1 equals mx minus x1. Okay. Y1 is this one. M is this one. X1 is this one. All right. So again, a lot of terms, right? So you simplify, and at the end you should get this thing. You see? No more t. Sorry, this one, this one, the gradient of tangent in t, in a, b, and t. You will get this in. Alright? Okay, then the last part, 8 marks, so it's quite long. This tangent cut the x-axis at A and the y-axis at B. Alright, so I show you the diagram. So this is a hyperbola. Just now we say, right, x squared minus y squared, so it's horizontal. Let's say P is here. Alright, let's say P is here. So this one is the tangent of P. So the tangent at P cut the x-axis at A and cut the y-axis at B. Okay? This is the diagram. Then the question say M is the midpoint of OA. So M is here. This is OA. So M is the midpoint. Then H divides BM in the ratio 2 to 1. BM. So B is here, M is here. So this is BM. So point H is here. Divided BM in the ratio 2 to 1. Okay, so this is the diagram. So what the question want you to find? Find the locus of H when t varies. They want locus of H. So remember the last few lessons I have said, when you are asking to find the locus of a point, you must try to get the coordinates of the point in the parameter. You get the coordinates of H in parameter t. Then after that, you eliminate the t. Similar step only. Alright? Okay, how to come to this? So you follow this step. First, you find point A and point B. No problem, right? You already have the equation, ma? You already have the equation of tangent. This one. Alright? So at point A, y 0 lo. So sub y 0. And get your point A. Then at point B, x 0, right? Because cut the y-axis, so x 0. So sub x equals 0 into the equation of tangent and get your coordinate. Alright, so no problem for AB. Yeah? Then you get A already just now, and O is the origin. So can you find M, midpoint? Use midpoint formula, right? Okay, and you need to calculate X only. Y definitely 0 lah, because on the x-axis ma. Y definitely 0. You just need to calculate the X. Okay, then now you find H. Because you need all this A, B, and M, then only can find H. Okay, I draw out this line BM bigger. I write it bigger, BM. So B here, M here. You have the coordinate for B and M already. So H is here. The question says H divided BM in the ratio 2 to 1. So this is the condition. Alright, BM, H divide BM in 2 to 1 means BH, HM is 2 to 1. Can. Then use the formula for the point of ratio. Remember this formula? Yeah, mu x1 plus lambda x2 over mu plus lambda means this is the mu. So mu multiplied with this x. This is lambda. Lambda multiplied with this x here. Okay, 2 plus 1, that is 1, 3. Y also. This mu multiplied with this y plus this lambda multiplied with this y. So you get your point H. So you see, excuse me. So you find your H in, parameter T. Maybe involve A and B also lah. Not the small a and small b. Alright. Then you use this parametric coordinate. So x equals this one, y equals this one. So find t in terms of xy. Means you find t in terms of xy, then you eliminate the t. Sub the t that you calculate, sub into either x or y, then you will get one equation without t, no more t. That is the locus of H. To do this step, remember just now the example 5.27? Example 5.27 that I showed you just now in your textbook, page 244. Okay, so remember this. My lamp no more battery. So it's quite dark. Gelap still can. Alright. Not bright enough my lamp, you see. I bought this one. So that it's brighter. But it's chargeable, so I didn't charge it. So the light is quite no more battery. It's okay, but better lah. Okay, so remember this just now we discussed. We find t already, then we use the parametric coordinate. X equals something in t, y equals something in t. Then we try to eliminate the t to find t in terms of xy. Then sub this t into either your x or y. Alright, then you see your t disappeared, and you will get something in x and y only. So this is the locus of point H. You follow similar step like this. This is example 5.27. That I have discussed just now in your textbook. Can I see? Here, can see. Alright, you follow this step. Okay, for this part. So you see, I know that this question is long, but I want you to challenge. Take this challenge. Okay, you do follow my steps slowly because it involves a lot of terms, I know. Alright, so I give you 1 week time to complete this. Then you upload your solution into the folder. Please when you write, try to use black color pen. and write it clearly. Because some of you, when you forward your quiz to the driver, really blur lah. It's so difficult for me to see. Okay, all right. So you please complete this one before Friday lah, huh? If tomorrow I have time to do another video, then I will try to do something. Continue lah. 5.2.3.4 parametric equation of a rectangular hyperbola. Rectangular hyperbola is actually more familiar in STPM. Alright, so if I have time, I will do a small part until here only. Okay, then this one I will do on Friday. 5244 chords, tangent and normal. This one very long. Oh, this part very long, you see. So many past year question. 1, 2. This one. Alright, you can see that this one more popular lah. Okay, and we have one more part, the intersection of curve. This one short. So Friday we can complete this one. So if I have time, I really will try to do this. Okay, and give you the video tomorrow. This is quite simple. Okay, then Friday only we complete the last two part. Then this week we will complete chapter 5. So next week we will start chapter 6, vector. All right, okay, thank you class.